Greetings. The objectives of this video is to classify real numbers, use inequality symbols, and to find absolute values. First problem says, given the set, well, we better define what is set. Set is a collection of objects. And if you look below, you'll see a collection of objects. They're all numbers in this set. And each of those objects is called an element. And so an element is a single object. So element equals object. Notice that in the set that both at the end and at the beginning we have these braces. There's a brace at the beginning and a brace at the end. And inside we have -4, -7/8, 0, 4/10, square root of 5, pi, 7, and the square root of 144. Those are the elements. Now, first we're to list all the natural numbers. We've discussed in a previous video what natural numbers are. They are counting numbers, and in this case we look and we see a counting number in there, 7. So we can put in 7, and actually in disguise there's another counting number, the square root of 144. Square root of 144 is equal to 12, and the reason for that is because 12 times 12 equals 144. So the square root of 144 is really 12, and that is one of the natural numbers. If you remember from the previous video, whole numbers. Whole numbers are the counting numbers. So let's put in 7 and the square root of 144, the natural numbers, and also one additional number, and that is 0. And we have 0 in the set. So there are the whole numbers. Now integers are the whole numbers, and so the ones that we have so far are 0, 7, and the square root of 144, which is 12, and also any negative natural numbers. For example, -4. So -4 is also an integer. A rational number is a number that can be expressed as a ratio of two integers, or as a repeating decimal, or as a terminating decimal. So for example, -4 can be expressed as -4/1. -7/8 is one integer over another integer. 0 can be expressed as 0/1. 0.4 can be expressed as 4/10 or 2/5. It's also a terminating decimal. So 4/10 is another rational number. And also we have 7, 7/1, and the square root of 144, which is really 12. And there's our rational numbers. Irrational numbers, those are something that we haven't looked at before. Irrational numbers are defined to be numbers which are on a number line that are not rational. Well, if you remember, rational numbers could be expressed as one integer divided by another integer, or as a repeating decimal, or as a terminating decimal. For our irrational numbers will be non-repeating decimals. So we'll look at them in decimal form and we'll see if they're non-repeating. For example, we have the square root of 5, and so let's take a look at the square root of 5. The square root of 5, and we can look at it by just taking the square root of 5 with a calculator. And when we take a look at it, we see it is a number that would be on the number line, but this is being rounded now to 9 decimal places, and you see there's no pattern that repeats, and it really goes on and on forever. It's just being rounded on the calculator. So the square root of 5 is a number on the number line, but it is not a rational number. And now let's take a look at pi. And what is pi? Well, pi is written this way. You write this symbol for pi, and the way you say it is pi, and that is pi. And what is it? Well, we can draw a circle and draw a diameter that goes through the center of the circle. If you measure around the circle, that's called the circumference. Divide that by the diameter, and you'll get the number pi. Now, both the circumference and the diameter will not be both integer values, so it's not a rational number. And as a matter of fact, when we look at pi on the calculator, there it is, 3.14. And once again, it's not terminating there, it's just being rounded to 9 decimal places. So pi is also an irrational number. There's our two irrational numbers. Now let's talk about real numbers. What is a real number? Well, a real number is any number that can be expressed, or any number that can be displayed on a number line. And so every single number that we've had in our set can be shown on the number line. There's a point that represents that number on the number line. And so we can list the real numbers. It's just every number we've had. It's the rational numbers, -4, -7/8, 0, and 4/10. Also, we can throw in our irrational numbers, square root of 5 and pi. And let's put in 7, 7, and also the square root of 144, which is 12. And there are the real numbers. Next, we would like to insert one of these two symbols to make a true statement. Now, what are these symbols? First is called the is less than symbol. Is less than. The second is the is greater than symbol. Is greater than. Now, how can you tell which symbol to use? Well, we need to see which of our two numbers here is larger and which one's the smaller of the two numbers. So let's mark on the number line where -1, -2 is, and -5/10 would be halfway between 0 and -1. It'd be right about here. There's -5/10. And -1 and 5/10 is between -1 and -2. There's where -1 and 5/10 is. You could see that -5/10 is larger than, or is greater than, -1.5 because it's more to the right on the number line. The next statement is 5 greater than or equal to 5 true or false? Well, 5 greater than or 5 equal to 5 is what that symbol means. And we see that yes, 5 is equal to 5, so that's true, even though 5 greater than 5 is not true. Only one of them has to be true, and so that we get a true statement. Now, for finding the absolute value, we need to define what absolute value is. Absolute value is nothing more than the distance from 0 to the number on the number line. So it's the distance of a number from 0. And distances are positive, so this will be always a positive number. Well, the more I think about this, it's not always positive. It could be 0 because the absolute value of 0 is 0. So I might have to make a change there. But let's first make a number line here and put where -7 is. There's -5, and -7 is out here 2 more places. There's -7, and what's the distance between 0 and -7? Well, you can just march over 7 units, so it's equal to 7. The distance is 7, a positive number. Also, let's check and see what the absolute value of 7 is. There is 7 on the number line, and once again it's just 7 units away from 0, so the absolute value of 7 is 7. Now I want to change that as always positive and instead put non-negative. So it's always non-negative. And that's all the time that we have this time. See you next time.